Well, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant, and we're going to be taking a look at questions 21 through 25 pretty well on this year's Fermat contest. So this contest was aimed at Year 11 students, and Year 11 students have had a year or two in Canada with working with quadratic expressions. All right, so this one it's not hard per se, but it is a good introduction to quadratics, and it's very interesting, I would say. There's some interesting parts of this problem. So let's take a look. We know that there's 2 points, P and Q, on this parabola with this equation, and the midpoint of the line P and Q is 0, 0. We're also told that P lies above the x-axis, and we want to find the y-coordinate of P. All right, so for my money, you want to be able to, given this equation, create a sketch very quickly. All right, so let's copy it out. Y is equal to minus 3x squared plus 4x plus 27. All right, so first thing, the coefficients, okay, these numbers that multiply the x squared term, the x term, and the constant, we call these, this one is C, this one is B, and this one is A. Okay, so C, in these cases, always tells us the y-intercept. This is easy to show because imagine that x is 0. So here x is 0, you have y is 27, because this term is 0 and that term is 0 when x is 0. So that's why that gives you the initial value, or the y-intercept. Right? The next one that I want to talk about is this b term. All right, the b term is under discussed and understood by students, but I'm going to show you the trick now so that you can understand it. Okay, if I were to do this, okay, I'm just going to cover this up and make it a good old line. All right, and pretend that it's not quadratic. All right, and I just show you 4x plus 27. All right, and I say that's my equation. What does it look like? Well, it has the same y-intercept as this line, but then it has a gradient 4 as it crosses the x-axis, or the y-axis, right? That's its gradient. But that's also the gradient of the parabola at that point. Okay, a parabola is a curve, so its gradient is always changing, but at that time where it crosses the y-axis, it has a gradient, and it just does exactly what the line looks like it does. The last thing to understand is what this a value does, and this is what allows us to create our sketch of the parabola now, is this parabola opens downwards, and meaning it's like an umbrella that shields you from rain. It's not like a bowl that would catch rain. Okay, if this was positive, the parabola would open upwards and be above the line that we just graphed. Because it opens downwards, it's peeling away from the line on both sides. So it looks something like this, okay? It's coming down like that and curving, and it's going up like this, and eventually curving down, coming that way. Okay, so it curves and it's symmetrical around some vertex. Cool, right? Yes, very cool. I just love this stuff. So now let me just extend my line just a little bit. I wish this kind of came down a little further, just to show you something. All right, so now we've got points P and Q, and the midpoint of P and Q is 0, 0. Okay, so let's draw on P and Q. We'll do it in black for fun. So here's the midpoint, 0, 0. And about where does it look like it will go? Well, maybe you might say like there, and there, let's say. P is above the x-axis, so that's P. Let's call it HK. And if this is the midpoint and it's collinear, well then Q must be negative H, negative K. That's really the twist in this question. All right, we have to recognize that that one up there has the same coordinates as that one down there, just the signs are flipped. All right, and that will create a straight line that goes through 0, 0, that has a constant gradient, and that has the same distance on both sides. Now, there's only going to be one point on this parabola that does that, or 2 points that do this thing, and we can find them. Okay, and here's how we would do it. First, let's input these points into the parabola. So I'm just going to do my work for point P over here, where we have xy is equal to hk. So I'm going to write down k is equal to negative 3h squared plus 4h plus 27. All right, and there's nothing else I can do with that. Don't try and factor or anything like that. We're not going to need that. Okay, next I might say like, well, what can I do with point Q? Okay, well, let's try point Q. That's where xy equals negative h negative k. All right, so this one looks like negative k is equal to negative 3 times negative h squared plus 4 times negative h plus 27. Okay, I'm just inputting into here and here for x becomes negative h and y becomes negative k. Okay? All right, so let's just get rid of those because it's getting busy. We'll let that sink in for a second. Oops. There's our equation. All right. Now, what are we going to do? Well, we've got two equations, and we really want to solve what h is and what k is. But wouldn't you know it, we can simplify this one a little bit. Negative k is equal to 3, but it's negative. H squared, because squaring a negative gives you a positive, minus 4h plus 27. And then why don't we just go ahead and multiply that whole thing by negative 1. K is equal to 3h squared minus plus 4h minus 27, okay? Times both sides by negative 1, so all of the signs in the problem change. At least all the ones that are outside of brackets. Don't go changing things inside of brackets. All right, so now we have two different expressions for k. So let's equate them, okay? So we have minus 3h squared plus 4h plus 27, this thing, is equal to this thing, 3h squared plus 4h minus 27. Kick everything to one side and equate your set your parabola equal to 0. So we have 0 is equal to 6h squared because we add 3h squared to both sides. And then we're going to subtract 4h from both sides. So that's 0. And then we subtract 27 from both sides. So that gives you minus 54. Dividing both sides of the equation by 6 gives you 0 is equal to h squared minus 9. And that gives you 0 is equal to h plus 3 times h minus 3. This factorizes as a difference of squares. Isn't that pretty? Wouldn't you know it, this one here is at minus 3 and this one here is at 3. Okay, so we now know that point P is 3 comma k. And point Q is negative 3 comma negative k. Cool. Let's go ahead and evaluate what k is now. That's what they want. They want to know the y coordinate of P. So all we need to do is write down y equals negative 3x squared plus 4x plus 27, and then set x equal to 3. Okay, so y is equal to negative 3 times 3 squared plus 4 times 3 plus 27. Wouldn't you know it, this is negative 27, this is positive 27. They cancel. And 4 times 3, in my experience, always equals 12. And 12 is the correct answer. It's pretty, isn't it? It's very mechanical, this question. You just need to have really strong, you need to have decent quadratics mechanics. It really helps to not go down dead ends, like to say like, ooh, maybe I can factor this thing and stuff, and just do the things that you need to do to find those points. For my money, starting with a visualization helps me understand what I need to do in a problem like this, and building the visualization quickly involves understanding what the role of C is, what the role of B is, and what the role of A is. in creating that sketch really fast, and then I boom boom, there's my points. And seriously, like making these sketches is like a 5-second affair. You're like, oh, I can visualize it, and then you're off to the races. So practice your quadratics, everybody, and have fun with math. Like I'm having fun with math. Bye for now, everyone.